Hello friends, welcome to School Student. Today we are going to see a very interesting and important topic in chemistry in finding the hybridization and geometry of a compound. This will be very helpful for you in finding the both in class 11 as well as your 12th grade and also your higher education. This simple trick will be very helpful for you, so please do pay attention till the end. Okay, and at last you will be given with do it yourself questions, and that questions will be very easy for you in solving if you watch out the video until the end. Okay, so let's get started. So the first compound is XeOF, XeO4. This is the first compound. Okay, first you have to be clear with the electronic configuration of whatever may be the atoms. Okay, see, this xenon is the noble gas. Noble gases will have how much valence electrons? 8 valence electrons. In its last shell it will be having 8 valence electrons. Okay, so first you have to write how much valence electrons it is having. So you have to write xenon and you have to keep dots. Dots represent electrons. Okay, 1 2 3 4 5 6 7 and 8. Okay, so 8 dots we kept. Then you have to go for making the bonds. Oxygen, how much oxygens we have? 4 oxygens. Okay, so oxygens will be always in double bonds. Okay, if the oxygen should be in double bond, then how much electrons it must be getting bonded with? 2 electrons. Okay, so these 2 electrons for the first oxygen, these 2 electrons for the second oxygen. Just a minute. These 2 electrons for the second oxygen, these 2 for the third, and these 2 for the fourth. Okay, so we bonded the neighbor atom. 4 neighbor atoms we have bonded. Now you must go for naming the shells. See, the first bond always you must start with S. The next one you should go with P. Okay, so I will explain this why I am naming so. Okay, so S means it is a subshell. S, P, D, F, these 4 are subshells. Okay, S will have 1 orbital, P will have 3 orbital, D will have 5 orbital, and F will have 7 orbitals. Okay, orbitals will be in square shapes. You might have learnt in the valence bond theories in pairing of the electrons. Okay, so this is what, this is S, this is P, and if 5 boxes are there, it will be D, and you will be giving electrons like this, right? 1 2 3, so this goes on like this. Okay, so keeping the orbitals in mind, we have written the SPDF subshells. So first one you have to go with S, the next 3 things you have to go with P. After filling 3 you have to go for 5 Ds. After 5 days you have to go for 7 Fs. Okay, so like this it goes on. Okay, so now we are done with this, and now let's go with what is the hybridization. After this, after writing this S, P, P and P, you have to go for the hybridization. That is, the hybridization is sp3, 1s, 3 p's. Okay, so sp3 hybridization. Now you have to check for the lone pairs and the number of lone pairs and number of bond pairs. How much bond pairs we have? 1 2 3 4. 4 bond pairs we have, but how much lone pairs we have? 0 lone pairs. No lone pair is present. If lone pair is present, there will be the change in the shape of the molecule. If there is no lone pair, then automatically for this hybridization, what will be the shape? That shape will be attained by this compound also. So for sp3 hybridization with 4 bond pair and 0 lone pair, the shape is tetrahedral shape. Okay, are you clear with this, my dear friends? Is this clear? That's it. See, first you have to find what is the valence electrons. Keeping the valence electrons in mind, you have to write that much electrons, and after this you have to see whether this oxygen will be, whether the neighbor atom will be capable for bonding single bond or double bond or triple bond. You have to see that. If it is so, you have to bond like that, and then you have to go for naming SPDF, and after that you have to find what is the hybridization. Using the number of bond pair and lone pair, you have to find the shape of the molecule. That's it. We are done. Okay. Is this very easy for you? Now let's go with the second example. Now we are done with the first one. So the first one, XeO4 molecule undergoes sp3 hybridization with 4 bond pair and 0 lone pair and has tetrahedral shape. Okay, now you got some idea in this. Usually we'll be finding these things using the valence bond theory or VSEPR theory or molecular orbital theory. But keeping that concepts in mind, you can do the problems like this. Okay, are you clear, friends? Now let's go with BRFI. BRFI. So BR, bromine. Bromine is what? Bromine is a halogen. Halogens will be having how many valence electrons? 7 valence electrons will be present. So you must start with bromine 7 dots. Dots represent electrons, right? So 7 electrons you have to keep it. 1, 2, 3, 4, 5, 6 and 7. How many fluorine we have? 5 fluorines we have. Fluorine will be getting 1 electron from the neighbor atom for finding single bonds. No double bond will be formed by the halogens. Okay, so 1, 2, 3, 4 and 5. That's it. 5 fluorines now we have bonded. After bonding this 5 fluorines, you have to see, you don't get panic that you did not pair up these 2 electrons. That is where with the trick is. See, these 2 are lone pairs. Okay, so lone pair is present in this case. In this case, in XeO4 we don't have lone pair, but in BRFI we have 1 lone pair. Okay, so now after finding this, you have to go for what? The hybridization. Yes, this F, and this. These 3 goes for P. And this last F, D, and this lone pairs together D. Okay, now what is the hybridization? This is 3 P's, right? So P3. So now the hybridization is sp3d. sp3d is the hybridization, or dsp3 is our hybridization. Both are same. Okay, so sp3d hybridization or dsp3 hybridization. After finding this hybridization, you must see how much bond pairs and lone pairs are present. See, we have 1, 2, 3, 4, 5. 5 bond pairs and 1 lone pair. Okay, so we have 5 bond pairs and 1 lone pair. If there is a presence of 1 lone pair with 5 bond pairs, then the shape of the molecule becomes square pyramidal shape. So the shape is square pyramidal. That's it. We are done. Are you clear, friends? See, BRFI 7 electrons, 5 with fluorine, 2 lone pairs. Name according to the sp3 or sp3d2. Like that you have to. Oh, I'm I'm sorry friends, see, it is sp3d2. Okay, see, two D's are there, I left this one D. Okay, sp3d2 hybridization or d2sp3 hybridization. With this 5 bond pairs and 1 lone pair, we'll be getting square pyramidal shape. That's it. Okay, I'm very sorry for that. So we got square pyramidal shape with this hybridization and this 5 bond pairs and 1 lone pair. Okay, now let's go for our third example, XeOF4, that is an oxo acid. Now our third example is XeOF4. So you just start doing along with me. It will be very easy for you. Okay. So XeOF4. Xenon has 8 electrons. Okay. So 8 dots you have to keep. Xenon. 8. 1, 2, 3, 4, 5, 6, 7 and 8. Okay. Now you must go for the bonding. How much fluorine we have? 4 fluorines we have. You first start with the single bond and then we can go for double bond. Fluorine. 4 fluorines we filled and then 1 oxygen is there. Oxygen goes for double bond, right? So oxygen, and these two are obviously our lone pairs. That's it. If you do like this, we are done with just 1 or 2 minutes. Okay, so now you just name for the hybridization. This is S, these 3 F's goes for P3, this oxygen D and this lone pair D. So our hybridization is sp3 d2 hybridization. Okay, for BRFI also the same hybridization we got, and XeOF4 also same hybridization we got. For BRFI also we got 1 lone pair. For XeOF4 also we got 1 lone pair. Obviously our 5 bond pairs and 1 lone pair. So obviously our shape becomes square pyramidal. Hence our resultant shape is square pyramidal shape. How I am writing these things? So you have to be clear with, in that 4th chapter of the 11th grade, you have to be that chapter contains a long table, right? So that table you have to be very clear. In that table we have, if this much bond pair and this much lone pair are present, what will be the shape? The shape will be changing according to the presence of lone pair alone. This question often will be asked in the board examination, how the shape of the molecule is determined. So the shape of the molecule is determined by the presence of lone pair and bond pairs. That's it. We are done with what we have to be done today. Okay, we are done. That's it. Hope my video was clear and I have well explained. If you have any suggestions to be said, please do comment it in the comments box, and be free to say what you want from me. Okay, thanks for watching the video. Please subscribe my channel and share it with your friends. Bye bye.